Hi there. In this video we're going to look at AQA's Mathematics Unit 1 for June 2011, and this is the higher paper. Okay, question 1. It says the stride lengths of 18 boys in Class A are shown to the nearest centimetre, and here is the data here. We're asked to show this data in an ordered stem and leaf diagram, and we're told to remember to complete the key. So for 1 mark we're going to write down the key as 81 represents 81 centimeters, and we have to build up our stem and leaf diagram. So I can see I'm going to need 6, 7, 8 and 9, and I'm going to cross them off as we go. I can see the lowest value is 69, so I'll put a 9 here, and next value on our ordered stem and leaf diagram is going to be 72, and we're going to build up the stem and leaf diagram. If you're not sure how to do that, do check out my video and you'll end up with something like this. The next question, 1b, it says the stride lengths of the boys in Class B are summarized in this table. So we're given a median and we're given the range, and we're asked to compare. And like I say in my video on comparing distributions, always comment on an average. In this case it's going to be the median, and always comment on the range. So what I'm going to need is I'm going to need the median for Class A. So if we return to our table here, our stem and leaf diagram, I need to find the median. So we've got 18 boys. That means the median boy will be between the 9th and 10th person. So let's find that person now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's in between 79 and 81. And halfway between 79 and 81 is 80. So I can say the median of Class A is 80. We also have the median of Class B. But let's work out the range of Class A. Class A, the range is going to be 91 take away 69. So the range of Class A is 22. So we got the median of Class A, we got the range of Class A. Now we can make our comparison. So what can I see? Well, boys in Class B seem to have an average stride length that's longer than Class A. So I can say on average Class B have a longer stride. Also, I can see that the range of Class A is bigger than Class B. So that means Class B are more consistent, or Class A is more varied. So what I've said here is the boys in Class A have a more varied stride length. And there are your 4 marks. It says, do you think the boys in Class B are older than the boys in Class A, and give a reason for your answer? Well, I would suggest yes, they are probably older because their stride length is bigger. They're probably taller. So the stride lengths on average is bigger. So that's your 1 mark. Question 2. A train ticket costs £23.50. The price increases by 6% and Felix has £100. Can Felix buy 4 tickets at the new price? So I need to increase the £23.50 by 6%. So I'm going to work out the new price by multiplying £23.50 by 1.06. If you like, you can work out 1%, work out 6%, and then add it on to the original amount. That gives us £24.91. And now I have to see how many times does £24.91 fit into £100. So I'm going to do a division here. £100 divided by 24.91. That gives me 4.01. Can he buy 4 tickets? For my final mark, yes he can. Question 3. A newspaper headline states, only 80% of teenagers think Winston Churchill was a real person. Show that the ratio of the number of teenagers who think Winston Churchill was real to those who don't is 4 to 1. So if we start out by just setting up 80% think he was real, that means 20% think he's not real. So we can write a ratio like this. Real to fake is 80% to 20%. Well, that's just the same as 80 to 20, and then simplifying our ratio, dividing both by Uh, 20, we get, or dividing both by 10, we get 8 to 2, and then dividing them both by 2, we get 4 to 1. So that's your 1 mark there. Okay, Hannah claims GCSE history students are more likely than other teenagers to know that Winston Churchill was a real person. Design a data collection sheet for Hannah to investigate her claim. So what we're going to need is some sort of two-way table with history students and non-history students, and then real and not real. So some sort of two-way table like this will get you your 2 marks. Question 3C. The ratio of history students who think Winston Churchill was real to not real is 17 to 3. Is Hannah's claim true? Well, remember, um, we're told that 80% of teenagers think Winston Churchill was real. So what we need to work out is what percentage of history students think he was real. Well, it's 17 out of 20 because there's 20 parts in total, and that gives us 85%. So is it true? Yes, it is. 80%, according to the newspaper headline, said that teenagers would think he was real. Hannah reckoned that it was history students would more history students would think he was real, and in this case, her claim is true. It says there are 56 more history students who think Winston Churchill was real to those who do not. How many history students are there altogether? Well, if the ratio was 17 to 3, that means 14 parts must represent the 56 people. So we had 17 to 3, 14 parts, that's the more part. If we do 17, let me change that. If we do 17, take away 3, that equals 14. So 14 parts must represent the more than bit. So 14 parts is 56. 1 part is going to be 56 divided by 4, 14, which is 4. That means we need to work out 20 parts in total. So 20 times 4 gives us 80. So 80 students in history altogether. Amir drops different balls from the same height onto a wooden floor, and he measures the height to the nearest 0.2 meters of the first bounce. The frequency polygon shows the results. Calculate an estimate for the mean bounce height. Now this is just like calculating, estimating the mean from a table. A frequency polygon, you should know, uses midpoints, and there's our midpoints there. So we have all the midpoints. I need to multiply the midpoints by the frequencies and then add them together. So I'm going to do midpoint times by frequency and then add them together. So what I'm doing is 0.4 times 2, and I'm going to add that to 0.6 times 3, 0.8 times 7, and so on. So we're doing midpoint times frequency. When we tidy that up, we get 17.2. So 0.4 times 2 is 0.8. 0.6 times 3 is 1.8, and so on. Adding them up, we get 17.2. I'm also going to need the total frequency, and I'll get that by adding the frequency for each midpoint. 2, 3, 7, 4, 5, and 1. So adding them up together, we get 20. And then finally, we're going to do this number here divided by the total frequency. So we're going to do 17.2 divided by 20, which is 0.86. So the mean is 0.86 meters. Okay, Amir wants to test a hypothesis. Balls bounce higher on concrete than on wood, and we're asked to use the data handling cycle to write a plan for Amir. And if you remember about the data handling cycle, first thing you got to do is state a hypothesis. That's already done. What we want to do now is collect some data. So what we're going to do is we're going to bounce a number of balls on concrete and record the result. we already have the results from bouncing on wood. So we're going to bounce them on concrete and record the results. How are we going to go about doing that? Well, I think we should drop the balls from the same height and um, collect all the results. So what we're going to do is we're going to drop them from the same height onto the concrete and record that height. Then what we're going to do is we're going to take our results and then put them into some sort of graph or chart. We've used a frequency polygon here. I think it would be advisable to use a frequency polygon again. So I'm going to draw a frequency polygon using the collected data. And then finally, I'd like to compare the frequency polygon for concrete against the frequency polygon on wood and see what we've got. I can also compare the estimated means. So if you put that down, you should get your 3 marks. 4C. One of the balls is dropped from a height of 0.2 meters. It says each time the ball bounces, it reaches 3/5 of its previous height. How high will it be after 2 bounces? So I need to work out 3/5 of 2 meters. So I'm going to divide 1.5 by 5 and then times by 3. I beg your pardon. I'm going to do 3/5 of 2 meters, which is 1.5, and then secondly do 3/5 of 1.5. So we find 3/5 of 2 to give us this, and then work out 3/5 of your answer to get 0.72. Question 5. A gardener plants 10 seeds each week from the same seed packet. The graph shows the relative frequency of seeds that germinate. It says 9 seeds out of the 10 planted in the first week germinate. Write down the relative frequency. Well, the relative frequency is the number of times, the number of observed outcomes. So in this case 9, divided by the number of times we've done the experiment, which is 10. 9 out of 10 is going to be 0.9. So I got to plot 0.9 with 10 on my frequency polygon, which is roundabout there. So that's A part 2 done. The next part, it says how many of the seeds planted in week 2 germinate. Well, if we remember, if we take the number of seeds that germinate and divide by 20, which is the number of seeds planted at week 2, I know that that's 0.55 from the graph. So just explaining that a little bit clearer, if we go up here from 20, we can see after 20 seeds, the relative frequency is 0.55. So to work out the number of seeds that germinate, we're going to have to do 0.55 times by 20, which is 11. Now I know 11 seeds at this stage have now germinated. But if we remember in the first week, or after 10 seeds, we had 9 that germinated. We had 9 out of the 10 germinated. So how many of the seeds germinated in week 2? Well, we got to do 11, because there's 11 in total now. Take away the 9 that germinated in the first week, which tells us only 2 germinated in week 2. Question 5C. There are 130 seeds in the seed packet. The label on the packet states on average 80 of these seeds will germinate. Is the statement fair? Well, what is 80 out of 130? 80 out of 130 is 0.62. Now if you go back to the relative frequency diagram, you can see that the diagram is heading towards 0.6. So it seems to be getting closer and closer to 0.6. So, is it fair? I would say yes, it is fair. Question 6. We've got a factory with 2 machines, A and B, that fill bottles with cola. Each bottle should contain 500 mils of cola. So we're given some information. We're asked to draw the box plot. Now, if you've watched the video on drawing box plots, this should be fairly straightforward. You plot your minimum, plot your maximum, your lower quartile, upper quartile, your median, and complete the box. And there is your box plot. So again, if you're not sure about how to draw this, do look at the video on drawing box and whisker plots. It's a handy 2 marks when you know what you're doing. Next question. It says the box plot shows the information about a sample of bottles from machine B, and the factory manager wants to replace one of the machines. Which machine should he replace? Well, if I was the manager, I would certainly be thinking about which machine is putting more cola on average into the bottles, and obviously a higher average is not good for the company, because, well, what we want is it said earlier in the question that each bottle should contain 500 mils of cola. So if we look at this box plot here, we can see that on average it seems to be putting 506 mils, whereas in this one here, this is 506, 7, 8, 508. So machine A is putting more on average. So machine A is putting a higher average, which is 508 compared to 506. So I would take machine A, and also I want to look at the consistency of the machines. Which machine is more consistent at filling the bottles? And the consistency is worked out by looking at the interquartile range. So if you look at the interquartile range for machine B, we can see that's 506, 507.5 compared to machine A, which has a far higher interquartile range, you can see, because the box is bigger. So machine B is more consistent. The interquartile range is smaller than A. Okay, it says the contents of the sample bottles are given to the nearest millimeter. Now this is important. Given to the nearest millimeter, and we're asked to work out the greatest possible difference between the contents of 2 of the sample bottles from machine A. So, well, if we go back to machine A, we can see that the maximum value was 514. If that was given to the nearest millimeter, that means the maximum could be 514.5. Let's go back again. If we see the minimum was 596, and again, remember, it was rounded to the nearest millimeter, that means it could have been 595.5. So, to work out the greatest possible difference, I'm going to do 514.5, take away 595.5, which gives me 19. So 19 milliliters is the greatest possible difference between the contents of 2 of the sample bottles. In general, if it's to the nearest millimeter, you halve that milliliter and add it on to give you the maximum, and take it away from the lowest to get the minimum. Okay, so it says factory buys 2 more machines, C and D, and 4 of the machines fill a total of 6,000 bottles each day. The sample stratified by number of bottles filled per day is taken. Some of the information about the sample is given below, so there we go. We're asked to complete the table. I would like to know what the sampling fraction was. So if I do 31 divided by 1550, that will tell me the sampling fraction was 1/50th. Now that makes life a lot easier to work out how many bottles from each one. If I do 24 multiplied by 50, that will give me what goes the number of bottles from B. What can I learn from this as well? If I have 1800 for D, if I divide that by 50, that will tell me how many bottles in the sample we used there, which is 36. So we know that. We know that. I need to work out C. Well, there were 6,000 bottles in total. So if I add this, this, and this, so I'm going to add these three values and then take them away from 6,000. That will tell me how many bottles we used there, which is 1,450. And then finally, I'm going to do 1,450 divided by 50 to get the number in the sample. So there's your 4 marks. Okay, it says a bag contains only black counters and white counters. Counter is chosen from the bag at random and replaced. If I know that it was replaced, that means we're dealing with regular independent probability. It says another counter is then chosen from the bag and it tells me the probability of choosing 2 black counters is 0.36. Show that the probability of choosing a black counter each time is 0.6. Well, if I choose a black, 0.6, and then I choose a black again, which is 0.6, 0.6 times 0.6 is 0.36. So the probability of getting 2 blacks is 0.36, and 0.6 times 0.6 is 0.36. So a handy first mark there. Work out the probability of choosing 2 white counters. Now before I go and do that question, it's a good opportunity to explain that this question, a nice way of doing it would be using a tree diagram. So I've built up a tree diagram here. So to begin with, we had black and white counters. Probability of a black counter is 0.6. That means the probability of a white counter must be 0.4 because it's only got black and white counters, and the total probability must add up to 1. We're going to choose a second time. We'll either get a black or white counter. Again, because it was replaced, the probability of a black is still 0.6. Probability of white is still 0.4. And if you work out the probabilities for the end of each tree, or the end of each set collection of branches, so you'll do 0.6 times 0.6 will give you the total probability of getting 2 blacks. 0.6 by 0.4 will give you probability of getting a black and a white, and so on. So multiplying across the branches, that gives you the final probabilities. So this will help us answer the question. The probability of choosing 2 white counters, well, if we go to our tree diagram, that would mean we chose a white and then we chose a white again, which is 0.4 times 0.4, which is 0.16. So what I've said here is the probability of choosing a white is 1 take away the probability of choosing the black, which is 0.4, and then we'll do 0.4 times 0.4 to get to 0.16. Next question says work out the probability of choosing at least 1 white counter. This question can be a little bit deceptive. So to choose at least one white counter, well, that means I either got a black and a white, which was this probability, or I got a white and a black, which is this probability, or I got 2 whites, which is this probability. So all I'm going to do is add up these 3 probabilities. So it's the probability of black and white, or white and black, or white and white. And I just add those probabilities together to get 0.64. Okay, and the last question here, we got Ella has these coins, 20, 10, 10, 1 and 1, and Jadine has these coins. Ella's going to take one of her coins at random and give it to Jadine. Jadine adds it to the coins, then Jadine takes one of his coins and gives it to Ella. What's the probability that Ella and Jaden now have the same amount of money? So there's going to be a bit of a swap. One of these coins is going to go in here, and one of these coins is going to go up here, and then they're both going to have the same amount of money. We've got to work out the probability that that happens. Right, well, because they have the same amount of money, what I would like to know is how much money would that be? So if I add up all the money and then half it, that will tell me how much each person should have. So 20, 10, 10, 2, 10, 10, and 2 will give me a grand total of 64p. So each person is going to have 32p. So we're going to have 32p and 32p each. How can that happen? Well, if for example Ella gave a 10p to Jaden, yeah, Jaden will certainly have 32p, but Jaden has to give a coin back, so Jaden's amount of money is going to go down. So it cannot be the 10p. It certainly cannot be the 1p. It must it must be that 20p. The 20p must go to Jaden. So Jaden now has 20p, 10p, 10p, and 2p. At this moment in time, Jaden has 42p and Ella has 22p. So Jaden is going to have to give one of these 10p's back. And in that scenario, they both have the same amount. So what's the probability that happened? Well, the first thing that must happen is the 20p that Ella has must go to Jaden. What's the probability that she chooses that 20p? She only has one 20p. She's got 5 coins in total. So the probability is 1 out of 5. And that means we're going to multiply that by, well, what's the probability that Jaden gives a 10p back? Jaden has two 10p's and Jaden also has 4 coins because Jaden now has the 20p. So it's going to be 2 out of, or not 2 out of 20, 2 out of 4. So we're going to multiply these probabilities together. 1 out of 5 times 2 out of 4 is 2 out of 20, which is 1 out of 10. There's your 4 marks. That's all from me. Hopefully you found the video useful. Best of luck with revision, and I'll talk to you again.